Sumpner test, and what exactly we are going to do in this test, or what parameters or what thing can be determined using this particular test. So when we talk about the Sumpner test, so of course this test is going to be conducted on transformer. The agenda, objective or aim or motto of this particular test is to determine the maximum temperature rise in transformer. We know that transformer during its operation losses are occurred in transformer. Due to these losses that is in the form of heat basically. So it is going to increase the temperature of transformer. Heart of any electrical machine is insulation. So accordingly, if the temperature exceed beyond the insulation capability of bearing capability of temperature, so it is going to collapse basically. There will be breakdown in insulation, so there will be damage in transformer. So we are interested to find out what is the maximum temperature rise in transformer. The second thing, this test can also is useful to determine the efficiency of transformer. Okay, why we are saying, you could notice here that we have written that it is not accurate if we are calculating the efficiency of transformer using Sumpner test, back-to-back test or load test. Like we are in position to calculate or estimate the efficiency of transformer using OCSC test, open circuit and short circuit test. Already I think if you try to recall, we have discussed the same thing earlier, that without loading you are getting, when you are in position to measure actual losses occurring in the transformer, that is iron losses and copper losses. Okay, you not need to load there. So whatever actual losses will be there, that according to that you will get accurate efficiency. Okay, so for conducting this test, Sumpner test, we require two transformer and that should be identical. So two identical units of transformer is needed for conducting this test. So you could see here we are having two transformer. Okay, this is your one transformer, this one is your another transformer, and if you will pay attention from this circuit diagram, that the primary and secondary, they are connected in certain fashion. Okay, so what you could see when you will pay attention, you'll find out in first transformer, in second transformer, if this is a primary, so the primaries that is connected, just see how it is connected, the first terminal and the first terminal, or you could say the second terminal, how it is connected. So you'll find out that the primaries are connected parallelly for conducting the Sumpner test on transformer. Okay, so here the primaries are parallelly connected and they are energized at a rated voltage and frequency. So you could recall that how we were conducting the open circuit test. It is on similar line. Okay, that you were conducting open circuit test at a rated voltage and frequency. However, the secondary, that was kept open circuited. Okay, so here you could see that two primaries are connected parallelly, they are energized with the same source, supply is the same here in this case, and what you need to do, you need to keep secondaries open. So the wattmeter which is connected in this circuit, that is going to give you the core losses or iron losses of transformers. So how many transformers are connected here? Two transformers. So whatever reading is going to given by or recorded by this wattmeter, that will be basically the losses in first transformer as well as second transformer. So the losses which is going to measure by the wattmeter 1, that will give the losses, core losses or iron losses for both the transformer. Okay, now you can connect two secondary of transformer in series with their polarities in phase opposition. So now the two transformer secondary that is connected in series, and the mandatory condition is that its polarity that should be connected in phase opposition. So how we can determine whether if you have connected the transformer, okay, in connecting series it is okay, but whether it is connected in phase opposition or not, that we need to determine. So for that purpose, what we will do, we are going to connect a voltmeter across this two terminal. Okay, so if this voltmeter is going to read a zero value, so it means that the transformer secondaries are connected with proper polarity, that is connected in series. The important thing is here that the voltmeter range what we have to connect it here, that should be double, basically double of any of the secondary winding, because you are connecting it in series. If this is not basically properly connected, then voltmeter is not going to read zero value, it is going to read some higher value. That's why the range is kept basically double of any transformer secondary, because both are identical, that's why we are calling it as any. Okay, and if suppose it is not reading zero, so what you need to do, you need to interchange the connections, and by interchanging this voltmeter, it should read zero basically. Okay, so it suggests that yes, your transformer that is connected in series with polarity, appropriate polarity. Okay, so here that is in a larger view, just try to show the complete diagram. We have also connected one wattmeter here. So basically this wattmeter that is going to measure the losses which will be copper losses for both the transformer. Okay, so here the voltage which you would be applying, that would be the fraction of the voltage, so that the rated current flows in the secondaries. Okay, so now what you need to do, you need to inject voltage in the secondary circuit by means of voltage regulator, and what voltage you have to apply so that the rated current flow in two series connected secondaries of transformers. So whatever reading is going to get, that will give you the full load ohmic losses. So your wattmeter 1, this is the first wattmeter, it is giving you the iron losses, and this is going to give you the copper losses for both the transformer. Okay, so if you want to calculate for one transformer, just divide it by 2, because both are identical transformer. Please remember, you are using the identical transformer here. Okay, so and when you are having losses, so you can easily calculate the efficiency. Okay, and if you want to measure the temperature rise, which is the main agenda, so what you need to do, you need to keep transformer under rated losses condition for several hours. Why we are keeping it for several hours? So that whatever the maximum value of temperature can attain by the transformer, you know that some temperature that would be basically the heat that will be dissipated to the surroundings. Okay, so whatever temperature heat it can carry, that can be obtained. That's why you need to keep it for in on condition or in lossy condition for several hours, so you are in position to measure the temperature rise. Practically we don't do it in our laboratory, but in testing lab, BHEL is having the testing lab, so there you could do. Bangalore is also having the transformer testing lab.